Michio Kaku, a well-known physicist, has talked about what he thinks about the new findings made by the James Webb Space Telescope, JWST. Kaku has made many important advances to the fields of physics. He recently said that the JWST has found 6 very large cosmic systems that scientists didn't think were possible. The possibilities are endless when it comes to how we can better understand the world. So, it is interesting and worth your time to watch these changes happen. Kaku is one of a kind in the scientific world. He is a physicist with both American and Japanese roots, and he is known as a master of both standard exploratory physics and quantum mechanics. Some scientists are more moderate and wary than Kaku, but he has been open to the JWST mission's surprising results. The fact that this well-known scientist has decided to speak out about what can no longer be hidden makes us happy. When the famous physicist talks about the finds made by the JWST, it's clear that he's excited and interested. He says that this has been a highlight that has caught his attention. Come with us as we talk about what Michio Kaku's discovery of these 6 huge cosmic systems means. As someone who has always been able to think outside the box, Kaku knows that Einstein's theories of relativity and Newton's laws don't fully explain how complicated the world is. Some of his colleagues don't agree with him, but he thinks that the new telescope's findings could possibly move the field of science forward. This has made both supporters and opponents of quantum mechanics worried and unable to sleep. But Kaku can't help but laugh at this situation. The JWST has found evidence of 6 very large galaxies that date back to the beginning of the universe. Even though they were made not long after the Big Bang, these other universes have more stars than ours. The cosmologists who found these unusual systems have named them universe breakers because their presence would change everything we know about the universe. The most popular idea about the Big Bang says that the universe was completely chaotic right after the event, and it took hundreds of thousands of years for the first solid objects to form. People used to think that complicated structures like galaxies would appear much later. Some of the newly found systems are even bigger than the Milky Way. Their extreme brightness suggests that they are making a lot of new stars every year, while our galaxy only sometimes makes new stars. It's still not clear when the first galaxies formed, and scientists have been having a hard time figuring this out until lately. Most people agree that at first, there may have been only a few stars or groups of stars that slowly joined together to form bigger structures. This led to the formation of dwarf galaxies that merged and changed over time. In the past, the idea that very large and well-organized systems couldn't have existed so early on has led to questions about whether the universe is much older than we thought or whether complex galaxies formed much earlier than we thought. Normal science is still trying to figure out how to deal with these new results, which is a problem. Also, some areas of physics have strongly rejected this finding, pointing to mistakes in the calculations used to figure out the age. While Kaku agrees with this, he also says that many old and false ideas are still around because of how well-known certain scientists are. After a lot of research showed that many of these theories were wrong, they were finally thrown out. To be honest, we don't know very much about how the world started. The Big Bang hypothesis was made in 1927 based on observations of the expanding world. Since the universe has been growing since the beginning, this means that it started from a single point. People couldn't even imagine a universe with a beginning and an end at the time. The thought of an endless, unending universe was beyond their grasp. Researchers are still having trouble getting a handle on this idea, but it's important to look at these options again. Researchers have been using the Big Bang theory for decades, but these new ideas don't fit with it. But science has shown over and over that reevaluating and being open to new, groundbreaking ideas are just as important parts of the scientific method as confirming specific theories and observations. People thought that stars and planets were fixed in the world and had clear places to live when Einstein was a child. We now know that everything in the universe is moving. Planets move around stars, stars move very quickly within galaxies, and galaxies themselves move across the universe. The universe's future is still unknown. Researchers today have to face hard truths, like the fact that hypotheses are not just guesses or facts until they are fully tested and confirmed by precise observations. The Big Bang theory came about when it was realized that galaxies are moving away from each other. This is called Hubble's law, and it led to the idea that the universe was expanding. This idea has been backed up for a while by data like cosmic microwave background radiation and the redshift of light from faraway galaxies. That being said, it's important to remember that people who thought the Earth was flat and the Sun went around it had proof for their ideas until new events or advances in technology made things clearer. We are going through a similar thing right now. Scientists thought that the new JWST would confirm what they already thought about the Big Bang. Instead, it showed them 6 systems that didn't seem to make sense. This is a good reminder that science is always changing, and researchers need to be open to new findings and be willing to rethink their old ideas when new proof comes in. Redshift is a way for scientists to figure out how far things are in the universe. The color of light changes as the light source and viewer move away from each other. This is called redshift, which is also called the Doppler effect. For instance, the sound of an engine gets louder as a car gets closer, and it changes as the car moves away. The same idea holds true for light. When something bright, like a star far away, comes toward us, the light changes to blue tones. When it moves away, the light changes to redder tones. Redshift is the name for this event. Physicists have turned redshift numbers into speeds and distances that can be used to measure things in space. It's important to keep in mind, though, that even small mistakes in these numbers can have big effects. The old ways of measuring are being looked at again, and it will be interesting to see what scientists find out about the newest discoveries in our world. It is important to think about whether these results are really due to mistakes in the measurements, or whether some experts are just denying the facts. A lot of thought and a close look at the study data and methods are needed to answer this question. As science moves forward, instruments like the James Webb Space Telescope often make us question what we thought we knew about the world. One example is the discovery of 6 huge cosmic systems that date back to the beginning of the universe. These cosmic systems go against the usual ideas about how galaxies form, which brings up important questions about the time frame and parts involved in the growth of big structures. Because it uses cutting-edge technologies, the James Webb Space Telescope, which takes the place of the Hubble Space Telescope, can see farther into space with great clarity. Astronomers can see into the past by using its ability to pick up light from very far away in the universe. This lets them study galaxies that formed billions of years ago. Models that say these big, old galaxies should have formed much later in the universe's past are called into question by the discovery of these galaxies. These discoveries have effects on fields beyond astronomy and into basic physics. They are forcing scientists to rethink established theories about the early universe, such as the theory of the universe's origin, which says that the universe started from a single point and has been expanding ever since. At first, observational evidence like the cosmic microwave background radiation and the redshift of faraway galaxies seemed to support this theory. However, the finding of galaxies that look too developed for their age makes this story more complicated. A well-known scientist named Michio Kaku, who is known for his work in both theoretical physics and popular science, has said something about these developments. Kaku understands how important the JWST findings could be and agrees with the idea that important observations should lead to changes in how scientists think. He talks about how important experimental evidence is for shaping our understanding of the world and how theories must always change to fit new information. The fact that these findings have led to debate shows how dynamic scientific inquiry is. One side says that the finding of early massive galaxies suggests that the universe has been forming for a longer time than was thought before. The usual belief is that galaxies change slowly over billions of years by merging and smaller things slowly getting bigger. This view disagrees with that. Skeptics, on the other hand, say that we shouldn't quickly throw out well-known models because we only have a small amount of actual data. They want to be careful and say that the surprising results might be due to oddities in how the data was interpreted or mistakes in the measurements. Redshift is an important part of these important studies. When galaxies move away from Earth, the light they give off changes to have longer wavelengths. This is called redshift. Astronomers can figure out how far away a galaxy is from Earth and how fast it is moving compared to our own galaxy by measuring the amount of redshift in its spectrum. This knowledge is very important for making models of how the universe evolved and for figuring out where galaxies are located in it. Because it can pick up on weak infrared signals, the James Webb Space Telescope can see galaxies that would normally be hidden by dust and gas in the early universe, which is called the cosmic dawn. By looking at the light that these faraway galaxies give off, scientists can figure out what chemicals were in the early universe and how the first stars and galaxies came to be. In addition to its effects on the universe, the finding of these early massive galaxies brings up philosophical questions about how science progresses and how people learn over time. Because of new findings and observations, scientific paradigms have changed. As new information comes in, theories that once seemed impossible or dangerous to test become more and more accepted. This process of theory, observation, and revision that happens over and over again is essential for progress in all science fields. Thomas Kuhn, a philosopher, came up with the idea of a paradigm shift, which is a big change that happens when problems with current theories lead to a major reevaluation of scientific principles. The finding of early galaxies with a lot of mass makes astronomers to rethink what they think they know about how the universe evolved and how the galaxies we see today came to be. It shows how important it is to stay open to new, radical ideas and to change views based on evidence from experiments. Astronomers and cosmologists are also trying to figure out what these new findings mean for how we understand dark matter and dark energy. These hard-to-find parts, which together make up a big part of the universe's mass and energy, are very important for creating the structure of the universe on a large scale. The gravitational pull of dark matter affects where galaxies are found and how fast the universe is expanding. Dark energy is thought to be what makes the expansion speed up. The finding of early massive galaxies puts new limits on theoretical models of dark matter and dark energy. This makes researchers want to learn more about these mysterious things. In theoretical physics, the finding of early massive galaxies has made people interested in different models of the universe once again. Some scientists think that the observed strange things could be explained by making changes to the normal cosmological model. For example, they suggest adding more dimensions or changing the laws of gravity. These theoretical ideas push physicists to find new ways to study the subject and come up with new theoretical models that can work with both existing observations and new data. The JWST's findings also have real-world effects on future space travel and the creation of more advanced astronomical instruments. By pushing the limits of what can be seen, the telescope gives us important information about the scientific difficulties of studying galaxies and other cosmic events that are far away. It shows how creative people can be and how hard scientists, engineers, and workers work together to plan, build, and run cutting-edge space observatories. Cosmologists are looking forward to more discoveries from the JWST that will change the way we think about the world. In the future, scientists may find more early huge galaxies. This would help us learn more about the different kinds of structures in the universe and how they form. These findings will help us continue to try to figure out the puzzles of how the universe evolved, and they will also make us more interested in how the physical forces that shape the universe interact with each other. Finally, the James Webb Space Telescope's finding of early massive galaxies is a big step forward in our study of how the universe began and how it has changed over time. It calls into question accepted ideas, creates fresh inquiries, and shows how constantly changing scientific finding is. From Michio Kaku's point of view, these events show how important it is to accept uncertainty and stay open to major findings as we continue to explore the universe's mysteries. With each new finding, we get closer to figuring out the big picture of the universe.